Let's graph rational functions by finding asymptotes, intercepts, and points. Let's graph a rational function by finding its asymptotes, intercepts, and additional points. Let's get started. First, let's analyze the function f of x equals negative 2x all divided by negative 9 plus 3x. I'd like to get started by rewriting the denominator so that it's in descending order, 3x minus 9. And then I would like to factor the denominator. Factor out a 3. I'm left with 3 times the quantity x minus 3. So now, part A, determine the domain of the function f. For a rational function, the way that we find the domain is the denominator cannot equal 0. So we will list our denominator and list not equal to 0. And we will solve for x. So we will divide both sides by 3, and we get x minus 3 does not equal 0. 3 divided by 3 is 1, so that's gone. 0 divided by 3 is still 0. Then we're going to add 3 to both sides, and we get x does not equal positive 3. That is our domain, so that's one way to write it. Or we could list the domain in interval notation. Here's positive 3, surrounded by all of the other real numbers on the number line. We're saying that the x value cannot be positive 3, but it's fine to be any other real number. So in interval notation, that starts with negative infinity. It goes up to 3, not including 3, union 3, not including 3, out to positive infinity. So in interval notation, that's what x does not equal 3 looks like. It's all real numbers except the number 3. So we'll list interval notation in our answer blank. Negative infinity to 3 united with the other set, 3 to positive infinity. Part B, find the equations of the vertical asymptote. Whenever the denominator is 0, that's when vertical asymptotes are created. We're not allowed to divide by 0. So if we're looking for a vertical asymptote, then we go ahead and set the denominator equal to 0. And we solve it the same way as we did before. And so we get x minus 3 equals 0, and then x equals 3. That's the equation for the vertical asymptote. X equals 3. So for the domain, the denominator cannot equal 0. For the vertical asymptote, the denominator will equal 0. So now, we look to see if there are any holes in this other part C now. So we've done A and B. Part C now is hiding in here. Are there any holes? So we look at our factors here, and none of the factors involving x canceled away. So I'm going to check no holes exists. Okay, we didn't have any canceling factors involving x. Now we move on to part D, find the horizontal asymptotes. Okay, so let's write some formulas down. So there's 3 case scenarios. Case A, whenever the degree of the numerator is equal to the degree of denominator, then what we get is a horizontal asymptote, HA, we're going to look at the leading coefficients. It's going to be this formula off to the side. Let's write it to the side. The leading coefficient of the numerator, divided by the leading coefficient of the denominator. So let's go find those leading coefficients. So back here, the leading coefficient in the top is 2. The leading coefficient of the denominator is 3. And we made sure that we listed, this is one of the reasons we listed the denominator and the numerator in descending order. We could have mistakenly chosen -2 and -9. And that brings me to, I have left off a negative, so I'm going to fix that now. Add that back in. But it's very important to place this in descending order so that we can choose the correct leading coefficients. So now the equation of the horizontal asymptote, and that's what's happening here. Our degree of the numerator is 1. Our degree of the denominator is 1. It's the highest power on x. This is the only power on x that's here now, except for the understood 0. So since these are our leading coefficients and the degrees are equal, 1 equals 1, now we just divide the coefficients, -2/3. Y equals the division of the leading coefficient of the top over the leading coefficient of the bottom. So that looks like this. Y equals -2/3. And so we're going to go ahead and write that in as our horizontal asymptote. Y equals -2/3. And I want to just tell you what the other case scenarios are. Case B, if the degree of the top is less than the degree of the bottom, then what we have automatically, the horizontal asymptote is y equals 0. Last case scenario, part C, if the degree of the numerator is greater than the degree of the denominator, then the horizontal asymptote does not exist. DNE. In this particular case, you will get an oblique asymptote and you will have to divide. Oblique or slant. But the case that we found, both degrees equal, so we had to divide the leading coefficients. Now for part E, it wants us to find the x-intercepts. X-intercepts. So we know what to do. We are going to let y equals 0 and find x. Let y equals 0, find x. Okay. So we're going to take this original function, in place of f of x or y, we're going to set it equal to 0. And we have -2x in the numerator. And we have -9 plus 3x in the denominator. So whenever a fraction is equal to 0, if you want the fraction to equal 0, that means the top has to equal to 0, not the bottom. If you set the bottom equal to 0, you will get a vertical asymptote. And here's why. 0 divided by any number is still 0. So 0 divided 5 ways is still 0. 0 divided into 1,000 equal pieces is still 0. So as long as the numerator is 0, then the entire fraction equals 0. So we're going to say in order for this to equal 0, then the top, -2x, has to equal 0. We divide both sides by -2. Again, dividing 0 by a number is still going to give us 0. So x equals 0. So we let y equal 0, and we found x to be 0. So the origin is the x-intercept. And this problem did request the x-intercept in ordered pair format. So we're going to list that 0, 0. If the origin is the x-intercept, it's automatically the y-intercept as well. This time we're going to let x equal 0 and find y. So we have our y, and in place of x, we're going to put 0 in. Negative 2 times x, negative 9 plus 3x. In place of x, we're going to put 0. And what we get is y equals 0 in the top, negative 9 below, because 3 times 0 is 0. And then 0 divided by any number is still 0. So we let x equal 0 this time, and we got an output of y of 0 as well. So we're going to go ahead and list the y-intercept as 0. So that is part E. G. We found the y-intercept in ordered pair format. Now, we need to choose some additional points. Because we're allowed to use the graphing calculator, we're going to do that. So we turn on our graphing calculator, we press y equals, and we make sure we enter our f of x. I like to protect the numerator in parentheses, divide it by the denominator in parentheses. That way you're not just dividing the numerator by negative 9 and then adding on 3x. So we want to make sure we have correct data entry. We can get a preview of the graph, but what we're interested in now is a table of solutions, because part I is asking for additional x values and their corresponding y values. So we want some ordered pairs, x and y values. Okay, so we're going to have to access the table function, and that's in blue. So we're going to have to press the blue key for the second row to get up there on that second row to access that command. So we're going to go ahead and do that. Second and table. And so we have a table of solutions. So let's make this easy for ourselves. We can't choose 0, 0 because we've already found that. So it's saying additional points beyond what we've already found. I look at 1 and then I notice that is paired up with 0.33333 repeating. That I recognize that as 1/3. So let's list that 1, 1/3. Then let's find some more points. Go down some more. I recognize 2. If we plug in 2, 2, 1 1/3. I notice 1.5, 2/3. 0.6 repeating is 2/3. So you are welcome to try any of those. I'm going to list 2, 1 1/3. Let's keep going. Notice 3. Trying to plug in the value 3, we get an error because remember in the domain that 3 was not allowed because it creates a 0 in the denominator. So it created a vertical asymptote. So that's exactly where we should find a vertical asymptote at x equals 3. At 4, let's do 4, negative 2 2/3. 4 for x, 2 2/3 for y, and 9, negative 1. Okay, so those are 4 additional points, any 4 that you would choose. And so now we're going to use all of this information to sketch the graph of f. This is multiple choice. I would like to go back and press the graph function, and I see that there is a vertical asymptote right here. I'm going to go back and press y equals because in part D we had the horizontal asymptote at y equals -2/3. So I'm going to add that line in, y equals -2 divided by 3. And I'm going to press the graph, and notice it sketched in a horizontal asymptote for me. And so I need to find the graph where the horizontal asymptote is there at -2/3. I can eliminate choices C and D because it has the horizontal asymptote up here at the positive area. Okay, so I'm going to eliminate those. Another reason I can eliminate D, it has one part of the graph and the vertical asymptote here in the second quadrant and the third quadrant, whereas my vertical asymptote is in quadrants 1 and 4. So I can eliminate B based on those grounds as well, the placement of the vertical asymptote. So that leaves me with A. So I'm going to select A. That looks most like the graphing calculator, and we are allowed to use a graphing calculator on the exam. So there you have it. We have analyzed a rational function. We determined the domain and range, the vertical asymptote, the horizontal asymptote, x and y intercepts, some additional points, and we used all of that information to sketch the graph of this rational function.